What's up, ninjas? Brendan here, and welcome back to 7 Days of Injective. And today is day 3, and we will be doing decentralized applications, or dApps. We'll be creating a browser-based application that talks to the smart contract that we created on day 2. First, we'll make sure we still have the same starter repo as before, and then we will configure the blockchain information for Injective testnet within the dApp. And then we will make our dApp detect and use the wallet interface that is injected by the wallet. And then we'll configure the details of the smart contract the dApp talks to. And finally, we will implement the user interface interactions to talk to the smart contract. And that's it for today. So the first thing we'll do is that in day 2, we have already cloned this Git repository that we have set up before. And now all we need to do is to cd into day 03. That's all we need to do, right? So we've already got the starter code in day 3 over here. So within the front directory, we can see all of these files. That's what we need to continue for today. Now, to talk to the blockchain from a web browser, we will use Web3 client libraries. So you may have heard of Ethers.js, which has been the standard for a long time. Today, however, we're going to be using VM. This is a newer, more lightweight library that's gaining a lot of traction among developers due to its performance and more intuitive developer experience. These libraries are essential because they handle the complex JSON RPC communication for us, and they also act as a bridge between our JavaScript logic in the dApp and the EVM wallet. All right. So the first thing that we're going to do within the dApp is to configure the blockchain information. To do so, we will open up the front directory, so cd into front, and within that, we are going to ensure that we have a .env file set up. So I'm going to copy the counter.json file, which we have created earlier on in day 2. So this is having compiled the counter.sol file, this one over here. Now, and the bytecode, etc. So all that information, we're going to copy this over here, right? Now, the next thing we're going to do is we're going to copy the example.env file. So cp. So I'm going to copy the example.env file to this .env file, and I'm going to open it up here. So here we see we have a port number, an RPC URL, and a smart contract ABI. Now, this ABI file represents the file that we just copied over. We don't need it anymore. We'll just close it. And then we also need the smart contract address. So I believe we still have the contract open from day 2. Yep, here we go. So here's the counter smart contract that we had earlier on. We have deployed and verified it. Now we're going to copy this address and simply paste that inside of here. We save that file. And yeah, now that the project is configured, it's almost ready to run. All I need to do is run npm install. And it's installed. All right, the next thing that we need to do is to talk about Web3 providers and EVM wallets and the relationship between them. So in our dApp, we need to access the user's wallet. Notice that in our configuration, unlike in the hard hat repo when developing smart contracts, there's no seed phrase and there was no private key, right? So when you install a browser extension wallet such as MetaMask, what does it do when you visit a dApp or any website? It injects a global object and is accessible as windowed up Ethereum within the browser's JavaScript environment. And what we're going to do is to take that object and pass it into VM's create wallet client method. So let's take a look at that within the dApps file, right? The JavaScript file. So let me find where it's implemented, right? Over here, right? So this create wallet client, it actually comes from VM, right? VM being the library I mentioned earlier on. And there we go. So we use create wallet client from there, and we take the Injective testnet configuration and we specify a custom transport. And this is where the injected Web3 provider comes from, window.ethereum, right? That's injected by MetaMask into the window global. Now, the next thing that we're going to do is to connect to a smart contract, right? This requires an ABI and the deployed address of the smart contract. Now, what we have done earlier on by copying the ABI into here, right, this counter.abi.json, this was the compilation artifact. We can see that we already have the ABI here, right? And then inside our .m file, right, we have specified the smart contract address. And so this is basically exposed through to the dApp via a server. And in case you're interested in that, we have the server.js, and you can see how that is all loaded up from disk, etc. That's not really a part of this tutorial. This is just a standard web server. But, just know that what the dApp does is it calls this API from the server and it gets the RPC URL as well as the address as well as the API object. So when we're inside the dApp, all of that is available to us. Now, we will use two main methods that is provided by VM named read contract and write contract, and we'll get into that in a bit more detail. But essentially, read contract is for fetching data, like checking the current value of from a method, a read method, and then write contract is for changing data, invoking the the update method. So in this case, the increment method. Now, read operations, as mentioned earlier on, are free and instant, while write operations, because they change the blockchain state, they need to be paid using gas fees, and it also requires assigned transactions. Let's talk about providers, ABIs, and the deployed address. So what do we need to pass into the read contract and the write contract functions that are provided by VM, right? And you'll see that they have address and ABI inside of that, right? And the reason for this is because the address is basically a hexadecimal string, and that's a location where our contract lives on chain. So essentially, where do I send this information to when I want to either query or when I want to make a state change, right? When I want to call a function, where do I actually call it? So that's what the address is for. Now, the ABI, which stands for Application Binary Interface, is also crucial. It is like a translation or dictionary object, right? It tells our dApp exactly how to format the data so that the EVM understands it. So when we want to call a function in the dApp, right, either a query function or a state change function for transaction, that needs to get converted into EVM bytecode before we send that transaction in, right? We can't send in the function call in plain text. So with the ABI, it knows what the functions are, what the parameter list is, etc., and then it can use that to convert our method names and the parameter values, etc., into the EVM bytecode, right? So that's a translation function. Conversely, when smart contract responds, the dApp receives EVM bytecode, and that also needs to be decoded, right, from this EVM bytecode back into readable JavaScript types. So this is essentially like a serialization and deserialization activity, as well as, how to construct the transactions. That's essentially what the ABI is for. So in our example, let's take a look at front/server.js. So I opened earlier on, right? We can see this API over here. And this is what it's used for, right? We can see that that returns the smart contract address as well as the ABI object. So the next thing to do is to use the UI to query the smart contracts. So when we hook it up, we're going to start with reading the counter value. So let's open up front, and then within that public, and then index.js. And this is the entirety of the front end code for the for the dApp that we're about to create. So firstly, we'll find that we have several methods over here, and what we've done is say, let's take a look at index.html, right? Just as a bit of a introduction, we have button wallet, we have button read, and we have button write. So going back to index.js, we're looking for the query function, right? Which is button read. And here we've added an event listener. Within the event listener, we have statewallet.client.read contract, right? So we've got an instance of the client object that we initialized earlier on, and now we're calling the read contract function, and we're passing in the address, and we're passing in the ABI, as well as the function name. Now there's no parameters, so we don't need to specify that, right? And then we get the result, and the result is parsed, and it is set inside as the HTML, replaces the HTML text of one of the HTML elements, right? Likewise, we're going to do some UI changes to update the smart contract. So this is where the transaction comes in. So we're going to create a write button, right? So this is the write will trigger a write operation. And this time we'll need to use the wallet to do that, right? So what we're going to do is go to button write, right? So we just get that there. And then we have an event listener, and that passes in the address and ABI as before, same as the read function. But this time we have got a function name that's different. Instead of value, it is increment. And then there's an argument where we pass in a value of 100n, n being big, so big integer. So that's just a value of 100, right? And we also specify which account to use, which is the account that we've connected using. All right. So let's actually see this in action, right? So npm run npm start. All right. And we see that it has started. Now it has this URL. Let's copy that URL and open it in the browser. There we go. So this is our dApp. Now let's open up MetaMask as well so we can see what's happening over here. So the first thing we want to do is click on the wallet button. Now, if this is your first time, right, using this dApp, which most likely is going to be the case, then you need to press the connect button, right? And there's a very good reason for this. The EVM wallets, they will not allow any random website to interact with your wallet. You have to actually give it permission to do so. And this is good, right? It protects you from malicious applications randomly requesting stuff. You actually have to say, this application, I'm okay with it, so I'm going to press connect, right? So now that it's connected, it has responded, and now the application is able to read the details. So you can see that I've got this wallet address showing here. Okay, great. Now the next thing is the read button, right? So just as a refresher, this is what will happen when I click on it, when I click on the read button. So it's going to output a result. So let's press the read button, and the current state of the counter is the value is 300. All right. Now the next thing I'm going to do is press the write button. Now the write button, just as a refresher, is going to execute this. Right? It's going to obtain the hash, and then it is going to display the hash over here. But when I press the button, it doesn't do what it wants to do immediately. Instead, MetaMask will pop up with a request. Now, there's this button over here with 3 sliders. If you click on it, it'll show you more details, and you can actually see what the transaction is attempting to do. So it's saying, I'm going to interact with a smart contract at this address, and I'm going to call and if you look at the data pane over here, I'm going to call the increment function, and it has 1 parameter, and that parameter's value is 100, right? Which does actually match exactly what we see here. So we can see that VM code translating to what's actually happening in the application and sent to the poll. Now, if I press cancel, right, and I have the option to do that, then basically nothing will happen, right? Because the transaction was never sent through. Now, if I, on the other hand, do that again, right, and I like this transaction, I'm saying that's okay, I verified it, I'm going to press confirm, and then you'll see increment method with a status of pending, and then very quickly you'll see that if the status has changed to confirmed. You'll also see a transaction submitted followed by a hash, and what we can do is click on that hash, open it in a new tab, and it'll open up in the block explorer, right? And so we can see that the transaction was successful, happened 20 seconds ago, and if you click on view details, you can see this is what was actually sent in the transaction, right? So that's actually the method name, right, that has been converted into its hexadecimal representation. And this is a parameter value, right? So this is a uint256, and its value is 64 in hexadecimal. That translates to 100 in decimal. All right. And then because the block explorer has the ABI, because the smart contract has previously been verified by us, we can also see the decoded input data. And so we can see this is actually called to this method called increment with 1 parameter, and that parameter's value is 100. So it's actually parsed the value and displayed it. All right. So that was the demonstration of our decentralized application. Right. Now, before we wrap up, I would like to solidify the difference between the 2 operations, read operations and write operations. So read operation is like looking at a public bulletin board. So anyone can do it. It is free, and you don't need a permission. You don't need a signature, none of that, right? However, write operations are different because you are updating the blockchain state. So you actually need to sign the transaction using a wallet to prove that that transaction was actually authorized by you. That state change that you're requesting of the blockchain, that you actually wanted to do it, right? In order to do so, after signing it, you're actually also paying a small fee, and that's known as gas, to the network. And this is to compensate the network for the storage and the processing that it needs to do. And after that, you get your updated blockchain state as long as it follows the rules of the smart contract and the transaction is accepted. All right, we have covered the theory and demos for day 3 on decentralized applications, or dApps. And if you haven't gone through the steps yourself yet, be sure to do so now. They will only take a few minutes to complete. And you have a couple of options to do so. One is to rewatch this video right from the beginning, or to follow the text instructions in the link tutorial down the description below. In the next video, we will have a short quiz with a few multiple choice questions. Watch that to self-assess your understanding of this topic. Thank you for watching, and see you in the next video. But before you go, note that this is a preview edition of the video that is part of the 7 Days of Injective course. We're creating the full version of this course with all the bells and whistles. So if you watched this far, I'm sure you'll be keen on that too. So do sign up using the form by scanning this QR code or clicking on the link in the description of this video. For now, on to the next video.